Hey guys, what's up everyone? Welcome or welcome back to another video from the AB3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we're going to be looking at the application of two very important formulas when it comes to solving for the size of an angle or the length of a side when we are facing a triangle that is non-right angled. Now in a couple of tutorials prior to this one, I had went through a concept as it relates to the application of the trig ratios. We also did some practice questions, and I also had a look at using the Pythagorean theorem. Do check those videos out. A link to those videos will be provided in the description box below, where you can at the same time smash that subscribe button, leave me a like if it is that the content here is of any value, and do not forget to share this out to your other math groups and math communities. Alright, so hopefully I'll give you some clarity on the application of the cosine and the sine rule. We're going to be doing some examples and we're going to get right into the video. Alright, so here we go. Let's get started. So basically, finding the length of a side or the size of an angle in a non-right angle triangle, we mostly focus on the use of the cosine and the sine rule. Alright, and those two rules are the most important formulas when it comes to finding the length of a missing side or the size of a missing angle in a non-right angled triangle. Now, we're going to be looking at two of the most common cosine rule application, and there are pretty much two scenarios that can be presented to you that will suggest that you would need to use the cosine rule. Now, here is scenario number one. Let's say, for example, we are indeed finding the length of a side. Then usually the situation that's presented is that for you to determine the length of a missing length on the size of a non-right angle triangle using the cosine rule, then if we are looking for a side, then we must be provided with two of its sides, which is marked by A and by B, and we must be provided with the angle that is between the two sides. Now, the diagram below here shows that the two sides that we are provided with are B and C. And you can see that we are provided with the angle that is between B and C. So the unknown side here is going to be indicated by the letter A. Now, that's the scenario. We must be provided with two sides and the angle between the two sides so we can find the third side. So the third side is always the side facing the included angle. Now, if that's the scenario that's presented to you, then it simply means here that we would say that the square on the unknown side of the non-right angle triangle is going to be equal to the sum of the squares of the other two sides minus 2 times the product of the two known sides multiplied by the cosine of the angle made by the two known sides. And so, as you can see here, we have labeled the unknown side A, which means that A squared is going to be equal to the sum of the two sides that we know, which is B squared and C squared. And we're going to be taking away 2 times the product of B and C. Those are the two sides that we know, multiplied by the cosine of the angle. Multiplied by the cosine of the angle that is between the two sides that we know. Alright, so hopefully that explanation is made clear for you as it relates to the scenario number one. Now let's have a look at an example of how we would know that we have to be provided, or we have to use the cosine rule to solve for an unknown side. So as you can see here is that we are looking for x, and we are provided with 7.8, and we are provided with 9.2, and we are also provided with the angle made by the side 9.2 and 7.8, so we can find the unknown side, which is facing the included angle. So all the criteria for the cosine rule have been met. So therefore then we are looking at using the formula a squared is equal to b squared plus c squared minus 2ab, 2bc multiplied by the cosine of the angle between the two sides. So based on what we have discussed earlier, a is representing the side that we're looking for. So therefore a squared is now going to be rewritten as x squared. And b and c are going to be the two known sides respectively. So in this case, I can say b is going to be 9.2 squared and c is going to be 7.8 squared. Subtract 2 multiplied by b, which is going to be 9.2, multiplied by c, which is 7.8, now multiplied by the cosine of the angle between, which is 22. And when you're working problems like these, guys, most of the time when you're in exam, you're probably working with a time frame. But if you work too fast and you're not careful, you might end up getting the question wrong because of time. So you've got to control the time as you're doing the question. So we go on our calculator and we precisely type in the values that we have here. And we say 9.2 squared. That's going to be, let's say here, x squared is equal to, when I square that value, I got 84.64. And I hope that you guys are working with me at the same time. Plus 7.8 squared. 7.8 squared is 60.84. So that's 60.84. Subtract. I will then go ahead and find the product of 2 times 9.2 times 7.8. And I got 143.52. And I'll then multiply by the cosine of 22. That's 0.927. Now I will still have to remember the laws of PEMDAS, the rules. So we know that we have to multiply before we add. But because we are separated by a minus sign, I can go ahead and do both simultaneously. So I can see then x squared is therefore equal to 84.64 multiplied by, plus 60.84. That gives me 145.48. And therefore 143.5 multiplied by 0.927. So that's, 143.5 multiplied by 0.927. I got 133.02. So if I go ahead and I subtract from 145.48, 133.02, I'll get 12.46. So therefore we see x squared is equal to 12.46. And so naturally, if I want to find x, I will have to take the square root of the right side, which is 12.46. So you're going to find here that the square root of 12.46 that's 3.53 rounded off. So x is equal to 3.53. And here we're in centimeters, so that's the distance there. All right, so that's pretty good. All right, so hopefully you're clear on that, and as you get accustomed to using the formula, you're going to move with a little bit more speed, but you've got to get a hang of how to correctly apply the formula, because many things can go wrong, especially sometimes. Most often you find that when the angle between the two sides becomes greater than 90, and we have to write a negative sign for the cosine of an angle greater than 90, we tend to always forget to multiply the two negatives and write a positive. So hopefully an example comes up in this particular tutorial where we can see that example happening. All right, now I want you guys to go right ahead and try to solve this particular question, and when you've done so, leave your answer down in the comment section below, and I will confirm with a thumbs up if it is that you are correct. Okay, so let me know in the comment section what is the answer for the following question. So we're going to be looking now at a scenario 2. How else can the cosine rule be applied? Now we've looked at how to use the cosine rule to find a missing length, but now here's the scenario for how we're going to use the cosine rule to find the sides of a missing angle. Right, and so according to the information on screen here, the cosine rule can also be applied in a triangle to find the size of an unknown angle. However, we must be provided with the length of all caps, all three sides. So we could be looking for the angle A, or possibly we could be looking for the angle B, or we could be looking for the angle C. Now, if we are looking for the angle, say for example, here we're looking for the angle C, okay, then notice here that we are provided with A, B, and C. We are provided with those three sides. But what we've got to be careful with when it comes to the formula, right? We already established in scenario number 1 that the unknown side is indicated by, say, A or B or C. So for us to use the formula, let's just rewrite the formula quickly here and see what is happening. We say here that, okay, so we say here that the formula for this is A squared. Let me just zoom this up a little bit, guys. So the formula is A squared is equal to B squared plus C squared minus 2BC times the cosine of the angle between B and C. Okay, so what exactly, if in the first scenario we said that the length of the side that is unknown is marked by A, in this scenario there is no unknown side. So what are we going to call our A? Well, A, according to our formula here, is going to represent the side that is facing the angle that is unknown. So in this case here, all right, let me just kind of get these out. All right, let me just get that out here, get that out here, get that out here. Okay, now just to make it easier, let us say that I wanted to find, say, the angle here that is marked by X. No, well, pardon me. Let's say I wanted to find the angle here that is the angle right here that is marked by X. Okay, let's take our eyes off the A, the B, and the C. So if I wanted to find this angle here, then that would mean that this side is going to be A, and therefore the other sides can be B or C. All right, now let's say now that we're actually trying to find the angle up here that is marked by X. Then therefore this side is going to be your A squared, or your A, and then the other two sides can be B and C respectively. And so if we wanted to find, say, the angle down here that is marked by X, then according to our formula, A is going to be the side that is facing the angle that we're looking for, and so therefore the other two sides can be labeled B and C respectively. All right, so you can see here that it's very important for us to establish what we are going to be calling A, depending on the example that we're given. So depending on which angle, then A is going to be the side that is facing the angle that you are looking for. So hopefully that clears up what do we represent as our A, B, and C. Now, with that said, let's hop into an example now here where it makes a lot more sense for us to work this out. So here we are instructed to find the angle marked X degrees. Here. And so we have to establish what, according to our formula, which is A squared is equal to B squared plus C squared minus 2BC multiplied by the cosine of the angle. Then we have to establish what we are going to be calling A and what we are going to be calling B and C. So since this is the angle that I'm interested in calculating, then I'm going to be using 16 to represent my A. And so B and C can be the other two sides respectively. So if we go right ahead here and we say 16 squared is going to be equal to 8 squared plus 22 squared minus 2 times 8 times 22 multiplied by the cosine of theta so 16 squared would have been, and cosine theta is going to be cosine x because x degrees is what we're looking for. So 16 squared is 256. 8 squared is 64 and 22 squared is 441. Pardon me, that is 484. Take away 2 times 8 times 22 and that's 352. And so then we're going to be multiplying by the cosine of x degrees. Now we're going to go right ahead and simplify a little bit more. So that's 256. That's equal to 64 plus 84. So what we're looking at here is 368. And then we have 352 multiplied by the cosine of x degrees. Now a common mistake, and I'm going to be highlighting it here, a common mistake here for students, when you're not using like a designed formula, like you have already rearranged the usual cosine rule and you've transposed the formula for x degrees, then you have to go through the process here of transposition. So a common mistake here is where students most times will subtract these two numbers. And so if you do that, then you would be basically breaking the rules of PEMDAS, because PEMDAS states that you have to multiply before you subtract. So there's no way that we could subtract the 352 from the 368. Because as you can see here, the 352 is what we usually see married to the cos x degrees. So therefore, we have to transpose because we need our cosine of the angle to remain positive. We need a positive variable. So we're going to be transposing here. We're going to have 352 cosine x. They go together. And that's going to be equal to 368 take away 256. So we just kind of swap positions with the cosine x times 352 with the 256. So you're going to find here now that 352 cosine x degrees is equal to 368 take away 256. and that's 112. Right, let's just skip over here, guys, get some space. So therefore I need cos x degrees to be by itself, so I'll simply divide both sides by 352. So cosine x degrees is equal to 112 divided by 352. So we're going to find that cos x degrees is equal to 0.318. So now we're going to be now we're going to have to use the inverse cos in order to get the answer for x degrees. We have already looked at an example in the trig ratio reverse rule where we find the arc cos of the angle here. So therefore we can say that x is equal to the cos inverse 0.318. And so cos inverse can be gotten on the calculator by hitting the shift button or the second function and hitting the function that you're working with, the trig function, which is cos. Type your number in, and the degree here is, to the nearest degree, is pretty much 72. So x degrees is approximately equal to 72. All right, so, or x is equal to 72 degrees. So that is how we basically apply the cosine rule in this particular question. Now, what I want you guys to do is to take the time out to actually work out this question down here, where we have this side to be 6, this side to be 9, and this side to be 8. And so I'm just going to be selecting the angle that I want you to find. I want you to find this angle here. Okay? So take a note of that, work the question, leave your answer down in the comment section. Now if you want to have some fun and you just want to practice using the cosine rule, then I want you to use the cosine rule again to find this angle. Then I want you to use the cosine rule again to find this angle. And the cosine rule, if it's true, which we already know it is, we can add these angles up and we should get exactly 180 degrees. So have some fun with that and let me know how it goes in the comment section below. Alright, so this brings us to the end of the part 1 tutorial. I will not be putting in this particular video the application of the sine rule, so I'm going to be posting another video on that. Let me know your thoughts in the comment section. Do take care until next time. This is Akeen, your math instructor. Continue practicing to improve your mathematical skills. Take care. Bye.